Inspired by my trip to Paris earlier in the year, I wanted to create an interactive sonic environment that would portray the sounds of Paris. Researching into soundscapes, I found the works of the World Soundscape project. Their work gave me an overview of what a soundscape can be. I took their ideas and wanted to break them down further. Rather than having a soundtrack-style piece of sonic art, I wanted to separate the sonic components and allow the audience to interact with the art. I began researching into different methods of using motion capture so that the audience would have to be physically present in order for my piece to work. I found Marie Sester's Access installation, which followed a member of the public around a gallery with a spotlight whilst playing sounds as though the light was talking to them. I then found Anders Lind's Lines installation, which was more melodic, playing notes from various instruments with the parameters of volume or pitch being controlled by the public's proximity to lines painted on the walls and floor. I was intrigued by Maria Sester's idea of one system being able to capture multiple members of an audience. I began by editing and mixing the various sounds I collected in Paris using Ableton. I figured that the easiest way to control the levels of these sounds based on position in the room was to leave the sounds in Ableton and use Soundflower as a cross-software audio interface, running the sounds from Ableton into Max. Within Max, I used the ADC tilde to separate the different channels of audio and be able to control the levels of these channels independently. In order to have the audience interact with these levels and be able to map out the room, I looked into using nodes, which within the system work great, being able to drag the cursor around the nodes and having the levels of the various channels change. However, when I tried to use the icon system, I ran into a problem. My plan was to suspend the one camera from the icon system in the middle of the room, having that run through Connect A to take care of the motion capture, and then send that data into Max in order to move the cursor around the nodes. When trying out the system, I quickly found that it was going to be incredibly unreliable. Connect A kept crashing, the camera wasn't picking up movement cleanly, and no OSC data was being received by Max. I felt as though I was almost going back to the drawing board. Abandoning that idea, I looked toward Anders Lind's Lines again, and thought about breaking up the motion tracking and having them run as independent systems. Now my idea switched to using several cameras, each mapped to the individual sounds. I decided to use the Xbox Connect cameras as I thought they would be more stable and more purpose-built for motion tracking. Quickly, I realised that my idea to split the tracking over multiple systems would be more involved than I thought. The downside to using the Xbox Connect cameras is that only one camera can be used and one computer, meaning that rather than having 5 cameras plugged into one computer, I now needed 5 computers, which meant I needed 5 separate Max patches. Within my Max patch, my audio is being played through a buffer, which is searching for the file name within the file preferences I set up. The audio is running from the receive fader through a groove object in order to loop the audio in the buffer sharing the same name. From here, the audio is sent through the live gain fader to the EasyDAC output. The Xbox Connect camera is tracking motion and outputting that data to Connect A. Here I set up Connect A to track and send an object's OSC data. Within Max, I use the UDP receive to look for the OSC data coming in on the same port the Connect A is outputting, in this case 3333. Connect A sends more information than I need, so I use the root object to route the object data to an unpack object in order to separate the XYZ data to individual outputs for each, seen as though I only intend to use the proximity or Z data for my project. In order to convert the numerical data into an audio signal, I use the sig tilde object, then running that audio MSP signal into an average tilde object to average and smooth out the data. From here, that data needed to be scaled so that the range corresponded to the volume of the audio when it hits the gain fader later on. In this case, the signal had a range of 0.2 to 0.1, so I mapped that to the minimum volume of -69 and maximum of 0 decibels. I use the change object, which only allows numbers or data through that is different to the last inputted, allowing the data to be less clunky and run smoothly. I noticed in testing the system that it was all working great, apart from when I moved out of the camera's range, the audio stayed at the level it was, depending on where I was last stood. To get around this, I had to come up with a way to tell the audio to fade out when there was no longer an object present. Within the max print window, I saw that every message printed had the argument object start, whether the data was being updated or not. So when no motion data was present, the message object start was still being sent. I routed this so when the input matches object start, it triggers a 0 message to a number, and when the input doesn't match, to send a 1 message to a number. From here, the number data is routed so that when the number matches 0, or in other words matches object start, it triggers a bang to a message box displaying -69 3000, which when sent to a line object turns the volume down to the lowest decibels, -69, over 3000 milliseconds. But when the object doesn't match 0, the volume will stay where it is. This controlling information is sent using a send fader object that sends information to the receive fader that controls the volume level of the live gain fader.